So during class today, we did not actually get around to screen recording during lecture time, but I wanted to at least walk back through and talk through what we did today. So the big concepts on the new pieces of today is we looked at the idea of going from something in logarithmic form into something that would be in what we would call exponential form. So I'll try to kind of talk through with my cursors to what's already written on the board here. So that you know what I'm talking about specifically. So if you've got something generically like log base a to the b, or log base a of b, equals x, you can convert this into an exponential form. The easiest way I try to remember it is the base of your log is also going to be the base of your exponent. So when we switch this over, a will be the base of both the log and now the exponent. And then we kind of just flip-flop these two values. So we're going to have a to the x equals b is the same thing as log base a of b equals x. So that's going to be our concept. If we were to look at something, for example, like number 7, we'd see that 2 is our base, so we would write 2 is the base of our exponent, to the third power equals our 8. So these are true statements, and so as we work through these, you can just verify they're true. And yes, 2 to the third power is 8. Similar with number 8, we would see that 3 squared equals 9. And so as we convert these into the exponential form, we see that come through. Now, two big concepts I wanted to talk about today was the idea that if you see log written without a base, it's always going to be log base 10. And then if you see something with ln, which we call the natural log, it's really log base e. And so if we're looking at something like the natural log of 1 over e to the third equals -3, to convert this into exponential form, the base of natural log, even though it's not written here, is e. So e to the -3 equals 1 over e cubed, which, yes, negative exponents is the thing that tells us to flip-flop and put us into a fraction. So there's kind of the first piece. The next piece we'll take a look at is going from exponential form into logarithmic. So now we're going the other direction. So we've got something like 4 cubed equals 64. And so again, the base of this exponent will be the base of our log. So log base 4 of 64 is going to equal 3. And again, these are just true statements. We're just converting them. And again, if we looked at an example with e, this would be the natural log of 20.086 is approximately 3. So we're flip-flopping these two values, and again, because it's e, we're going to have this natural log idea. It's log base e. We're going to take that information then to help us out with solving and evaluating some of these logarithms. So if you saw something like log base 4 of 4, what is that going to equal? Well, we can pretend that there's kind of this equals some unknown. And now as we convert this into an exponential form, we see that 4 to the x equals 4. And in this case, we realize that means x must equal 1. So log base 4 of 4 is 1. In fact, more generically, any log of the same number as its base, so even like log base 10 of 10, or just log 10 more generically, would also equal 1. Log base 2 of 2 would be 1, and so on and so forth. So then we can look at something else. So for example, number 42, this similar approach would be 12 to some power, so x is going to be equal to 144. And so we know 12 to the x equals, and if we use the stuff from last night, we know that 144 can be written as 12 squared. Now with our uniqueness property, we can say that x equals 2. Last piece you'll see tonight is going to be evaluating stuff with our calculator. Log 50, you can literally just type that into the calculator, log 50, enter, and it'll give you a decimal, which I believe is around 1.7. One thing I do want you guys to notice is we can do the same approach, so this would be 10 to some exponent equals 50. And so if you were to estimate what this would be, you should recognize that 50 is greater than 10, but less than 100. And I show those two numbers because if x was 1, 10 to the first power is 10. If x was 2, that would be 100. And so we know that log 50 is somewhere between 1 and 2 for a similar reason to like what we used to do with radicals where you're trying to estimate them. Another example would be log base 2 of 55. You know that 55 is between 32 and 64. So, this should be my x value here, not 2. So my log base 2 of 55 should be somewhere between 5 and 6. So that's what we got going tonight. Hopefully that helps, even though you didn't get to watch me actually go through and write it, but we talked about what we did in class. So good luck. If you got more questions, come see me tomorrow.